When we think about what makes flying safe, our minds usually jump to the incredible machines themselves. We think about the engines, the computers, all that amazing technology. And we figure if something goes wrong, it must be because a piece of hardware failed. But what if the weakest link in that whole chain isn't metal at all? What if it's way, way more complicated than that? So let me just ask you straight up. What do you think is the most dangerous part of a modern plane? I mean, is it the engines, spinning thousands of times a minute? Or the wings, holding the entire thing in the air? Maybe it's the landing gear, taking that huge impact, landing after landing. What's your guess? Well, the answer is probably not what you're thinking. It's none of those things. Take a look at this chart. It breaks down accidents that are chalked up to the human factor. And that massive blue slice of the pie. Wow. A staggering 73% is attributed directly to the pilot. Which means, as crazy as it sounds, the most dangerous part of an airplane is often the person sitting in the cockpit. And that, right there, leads us to the real focus of aviation safety today. It's this unexpected culprit we call human factors, which, as we're about to see, is a lot bigger than just simple pilot error. Let's just let that number sink in for a second. Over 73%. In commercial aviation, that's how many accidents point to human factors as a major cause. We're talking nearly 3 out of every 4 incidents. Now, this isn't about pointing fingers or blaming pilots. It's about getting real and trying to understand the incredible complexity of how people perform under intense pressure. And here's the thing. Human error isn't just one mistake. It's a whole bunch of different things. It could be a breakdown in what's called situation awareness, basically losing track of what's happening. It could be a bad decision or a simple miscommunication between the crew. And then there's that terrifying one at the bottom, controlled flight into terrain, or CFI. That's when a perfectly good, fully functioning airplane is accidentally flown into the ground or the ocean or the side of a mountain. So, to really get to the bottom of why these things happen, we can't just look at the pilot in isolation. We need a way to understand how a person interacts with the insanely complex world of a modern cockpit. And luckily, the aviation industry has developed a really powerful model for this. This is where something called the shell model comes in, and it's a game changer for thinking about safety. The big idea here is that an accident is almost never just one person's fault. It's a failure of the entire system, and the human is just one piece of that much larger puzzle. And this diagram shows it perfectly. It's called shell. Right there in the middle, you've got L for liveware. That's the person. And they're interacting with all the other pieces. The S for software, H for hardware, E for environment, and that second L for the other liveware, their crewmates. An accident happens when there's a problem, a mismatch right at the edges where any of these blocks meet. Okay, let's break that down. At the very center, you have liveware, the pilot. They are constantly interacting with the hardware. That's the physical plane. Its switches, its screens, the yoke. Now think about it. If a switch is poorly designed, or a display is confusing, that's a mismatch between the human and the machine. That's a potential accident waiting to happen. Then you've got software, and we're not talking about code on a computer. This software is all the rules, the procedures, the checklists. And finally, there's the environment. Everything from the weather outside to the air traffic control in their ear, even the pressure in the cabin. If any of these interfaces break down, you're in trouble. So the real takeaway is, safety isn't about creating perfect pilots. It's about perfecting the connections between the pilot and their entire world. Let's dig into a really powerful example of that interaction between the pilot, the liveware, and their environment. We're going to look at the pure physical battle a pilot's body wages just by flying high and fast. I want you to meet hypoxia. It is a silent killer in the world of aviation. See, as you go higher, the air gets thinner, which means less oxygen. If an airplane loses cabin pressure, the amount of oxygen available to the pilot just plummets. And the absolute scariest part, it can sneak up on you with almost zero warning. Now, this is genuinely chilling. This shows you the time of useful consciousness if the cabin suddenly depressurizes. At a normal cruising altitude, say 35,000 feet, a pilot has maybe 15 to 30 seconds to figure out what's happening and get their oxygen mask on. Go up to 43,000 feet, and that time drops to just 5 or 6 seconds. That's it. After that, they can't effectively help themselves. And during those precious few seconds, this is what's happening inside their body. Their vision starts to dim, their hands might shake,
But then the really weird part kicks in, a feeling of euphoria. A pilot might actually feel great just moments before they're about to pass out and lose control of the plane. It's just a brutal, classic example of a physical human limitation clashing with the environment of flight.
And it's not just altitude. High G-forces, like the kind fighter pilots or acrobatic pilots pull, can literally stop blood from getting to the brain. This is called stagnant hypoxia, and it causes your vision to fade to gray, a grayout, or disappear completely in a blackout. It's just another way the environment directly attacks a pilot's ability to do their job.
So, if we know humans have all these unavoidable limitations, how on earth did flying become the safest way to travel in history? Well, the answer wasn't to try and find superhuman pilots. The answer was to build a much, much better system for regular humans to work in.
And that system is called Crew Resource Management, or CRM. It's a whole philosophy that basically starts by admitting that humans are fallible. We all make mistakes. So the goal is to build a safety net around that fact, using things like teamwork, clear procedures, and open communication.
CRM really boils down to two main pillars. On one hand, you have cognitive skills. That's all about how an individual pilot thinks, how they stay aware of their surroundings, solve problems, and make good decisions. But just as important are the interpersonal skills, how the whole crew talks to each other, works together, and even challenge each other in a respectful way to catch mistakes before they snowball.
And the end goal of all this training is to build these exact qualities you see here. It's about creating pilots who have rock-solid situational awareness, who are expert communicators, and who can work flawlessly as a team. Good CRM turns a bunch of people in a cockpit into one single powerful unit that can handle stress and make the right call when it matters most. So the next time you get on a plane, just remember this. Your safety doesn't depend on one heroic pilot with nerves of steel. Honestly, that's just a movie myth. The reality is that the safest flights are flown by really well-trained, really well-prepared, but fundamentally normal, fallible humans. And they operate inside a powerful system that's been designed from the ground up to expect their mistakes and to catch them. It's a system built on one humble idea: embracing the human factor. And that kind of leaves us with one last question to think about. Whether you work in medicine or tech or you manage a team, every single field has its own version of the human factor. So the real question is, what could your world learn from aviation's relentless, life-saving obsession with understanding the human in the machine?